Welcome to Foundations of Prompt Engineering. In this course, you will learn to create and optimize prompts for a variety of generative artificial intelligence, generative AI, models. You will learn the principles, techniques, and best practices for designing effective prompts. Basics of foundation models. Generative AI is a type of artificial intelligence that can create new content and ideas, including conversations, stories, images, videos, and music. Like all other AI, generative AI is powered by machine learning (ML) models. However, generative AI is powered by very large models, commonly called foundation models. FMs are pre-trained on a vast corpus of data, usually through self-supervised learning. Understanding FM functionality. The size and general-purpose nature of foundation models make them different from traditional ML models. FMs use deep neural networks to emulate human brain functionality and handle complex tasks. You can adapt them for a broad range of general tasks, such as text generation, text summarization, information extraction, image generation, chatbot, and question answering. FMs can also serve as the starting point for developing more specialized models. Examples of FMs include Amazon Titan, Meta Llama 2, Anthropic Claude, AI21 Labs Jurassic 2 Ultra, and more. Types of FMs. FMs can be categorized into multiple categories. Two of the most frequently used models are text-to-text models and text-to-image models. Let's learn more about each of these types of models. Text-to-text models. Text-to-text models are large language models, LLMs, that are pre-trained to process vast quantities of textual data and human language. These large foundation models can summarize text, extract information, respond to questions, create content, such as blogs or product descriptions, and more. Text-to-image models. Text-to-image models take natural language input and produce a high-quality image that matches the input text description. Some examples of text-to-image models are DALL-E 2 from OpenAI, Imagen from the Google Research Brain Team, Stable Diffusion from Stability AI, and Midjourney. LLM. Large language models are a subset of foundation models. LLMs are trained on trillions of words across many natural language tasks. LLMs can understand, learn, and generate text that's nearly indistinguishable from text produced by humans. LLMs can also engage in interactive conversations, answer questions, summarize dialogues and documents, and provide recommendations. Because of their sheer size and AI acceleration, LLMs can process vast amounts of textual data. LLMs have a wide range of capabilities, such as creative writing for marketing, summarizing legal documents, preparing market research for financial teams, simulating clinical trials for healthcare, and writing code for software development. Understanding LLM functionality. Most LLMs are based on a transformer model. They receive the input, encode the data, and then decode the data to produce an output prediction. Transformer models are effective for natural language processing because they use neural networks to understand the nuances of human language. Neural networks are computing systems modeled after the human brain. There are multiple layers of neural networks in a single LLM that work together to process input and generate output. Neural network has 3 layers. Embedding layer. The embedding layer converts input text to vector representations called embeddings. This layer can capture complex relationships between the embeddings, so the model can understand the context of the input text. Feed-forward layer. The feed-forward layer consists of several connected layers that transform the embeddings into more weighted versions of themselves. Essentially, this layer continues to contextualize the language and helps the model better understand the input text's intent. Attention mechanism. With the attention mechanism, the model can focus on the most relevant parts of the input text. This mechanism, a central part of the transformer model, helps the model achieve the most accurate outputs results. Fundamentals of prompt engineering. Prompt engineering is an emerging field that focuses on developing, designing, and optimizing prompts to enhance the output of LLMs for your needs. It gives you a way to guide the model's behavior to the outcomes you want to achieve. Prompt engineering is the fastest way to harness the power of large language models. By interacting with an LLM through a series of questions, statements, or instructions, you can adjust LLM output behavior based on the specific context of the output you want to achieve. Elements of a prompt. A prompt's form depends on the task you are giving to a model. As you explore prompt engineering examples, you will review prompts containing some or all of the following elements. Instructions. This is a task for the large language model to do. It provides a task description or instruction for how the model should perform. Context. This is external information to guide the model. Input data. This is the input for which you want a response. Output indicator. This is the output type or format. Best practices for designing effective prompts. Be clear and concise. Prompts should be straightforward and avoid ambiguity. Clear prompts lead to more coherent responses. Craft prompts with natural, flowing language and coherent sentence structure. Avoid isolated keywords and phrases. Bad prompt. Compute the sum total of the subsequent sequence of numerals 1, 8, 10, 12. Good prompt. What is the sum of these numbers? 1, 8, 10, 12? Include context if needed. Provide any additional context that would help the model respond accurately. For example, if you ask a model to analyze a business, include information about the type of business. What does the company do? This type of detail in the input provides more relevant output. The context you provide can be common across multiple inputs or specific to each input. Bad prompt. Summarize this article. Insert article text. Good prompt. Provide a summary of this article to be used in a blog post. Insert article text. Use directives for the appropriate response type. If you want a particular output form, such as a summary, question, or poem, specify the response type directly. You can also limit responses by length, format, included information, excluded information, and more. Bad prompt. What is the capital? Good prompt. What is the capital of New York? Provide the answer in a full sentence. Consider the output in the prompt. Mention the requested output at the end of the prompt to keep the model focused on appropriate content. Bad prompt. Calculate the area of a circle. Good prompt. Calculate the area of a circle with a radius of 3 inches, 7.5 centimeters. Round your answer to the nearest integer. Start prompts with an interrogation. Phrase your input as a question, beginning with words such as who, what, where, when, why, and how. Bad prompt. Summarize this event. Good prompt. Why did this event happen? Explain in 3 sentences. Provide an example response. Use the expected output format as an example response in the prompt. Surround it in brackets to make it clear that it is an example. Bad prompt. Determine the sentiment of this social media post. Insert post. Good prompt. Determine the sentiment of the following social media post using these examples. Post. Great pen is equal to positive. Post. I hate when my phone battery dies is equal to negative. Insert social media post is equal to.